Welcome to the Explainer. Okay, so you've got a brand new mining claim and you're ready to start exploring. But getting a proper grid laid out without completely emptying your wallet? Yeah, that can feel pretty intimidating, especially if it's your first physical exploration project. The upfront costs alone can be staggering. But don't worry, because today we're going to break down exactly how you can take control of this entire process yourself. Picture this for a second. You are actually standing right out there on your claim, surrounded by absolute wilderness. You're ready to start your physical exploration, right? But before you can take a single soil sample or run a magnetometer, you desperately need a coordinate system so you can actually locate and map your features. Because without a grid, you're essentially just flying blind in the bush. And here is the massive roadblock for a lot of independent prospectors. $9,000. Hiring a professional, ground-based survey crew to cut a standard 12-kilometer grid can easily run you $9,000, and that's before taxes and mobilization fees. Look, when you are trying to prove up a claim on a shoestring budget, dropping nearly $10,000 literally just to draw invisible lines on the ground, well, it's a really tough pill to swallow.
So we need a cheaper alternative. Today, we'll quickly run through what line cutting actually is, how to design your grid, the affordable toolkit you need, the exact setup steps, and crucially, field safety. Let's get right into it.
Section 1. What is line cutting? At its core, line cutting is simply about establishing a physical, known framework right there on the ground. Basically, you're clearing these narrow little paths through the vegetation, and it's really important to keep them under 1.5 meters wide, to minimize your environmental impact. You start off with a central baseline that runs right through the middle of your survey area. From there, you cut a series of grid lines, or what we call wing lines, running off that baseline at perfect 90-degree angles. Then, you mark the whole thing with wooden pickets that have your coordinates written right on them. When you look at it from above, it's actually highly structured. It's like a giant coordinate system overlaid on the forest. You've got your primary vertical wing lines, let's say they're about 850 meters long with a 250-meter offset, and those are intersected by horizontal tie lines running across the top and bottom. This is the exact framework you're aiming to recreate out on your own claim.
Moving on to Section 2, Grid Design.
Before we go chopping any branches, we really need a solid strategy to maximize our chances of actually detecting anomalies. The absolute golden rule here: orientation. To avoid missing any linear conductive bodies, your grid has to cross the strike of your expected target at a perfect right angle. Think of it kind of like looking for a buried pipeline. You want to walk across it, not parallel to it, right? Because if you walk parallel, you might just step right between your lines and miss the whole thing completely. Now, sure, steep topography or maybe a lake might force you to adjust a bit, but your main goal is to always stay perpendicular to whatever geological structures you're hunting for.
All right, Section 3, the affordable toolkit.
This is where things get really cool, and where we actually save that $9,000. Professional surveyors use something called a theodolite. It's a gorgeous, highly precise, and extremely expensive optical instrument for measuring angles. It's fantastic, but it's not strictly necessary for basic exploration grids. In a pinch, your everyday smartphone sensors and a standard consumer GPS unit can absolutely get the job done for a fraction of the cost. It's a totally viable DIY alternative. Your affordable arsenal is literally probably sitting in your pocket or down at your local hardware store. You can download smartphone apps. Some are actually just called theodolite or angle meter, and they use your phone's built-in gyroscopes to measure angles surprisingly well. Combine that app with a standard handheld GPS to lock in your baseline control points, a simple laser distance measurer or a long measuring tape, plus a compass, and boom, you have a complete layout kit.
Section 4. Setup steps. Let's talk about the actual physical execution out in the dirt. Here's your exact DIY workflow. First up, you grab your handheld GPS to set up your starting point on the baseline. Next, you pull out your smartphone, open up your angle app, and turn a precise 90-degree angle so you can establish that wing line. Once you've got your direction locked in, you use your laser measurer or your tape to measure out the distance. Finally, you chain the line. That just means you place a marked wooden picket every 25 meters. You label them systematically, so your baseline picket might say L100E, the next one on the wing line is L100E plus 25, then plus 50, and so on. Slap some bright orange paint or flagging tape on there and they'll be highly visible in the bush. Section 5. Field safety. Working out in the bush means dealing with heavy equipment, really tough terrain, and unpredictable wildlife. So a strict reality check on safety is absolutely non-negotiable. You've got to have a rigorous daily routine.
every single morning has to start with inspecting your gear, checking your PPE, your first aid kit, and your bear spray. Before you even step foot into the trees, you must log your planned route on a tracking board back at camp. Throughout the day, maintain regular radio contact. And if something goes south, your entire crew needs to already know how to execute your specific emergency response plans. No exceptions.
Now, since clearing that 1.5-meter path usually means firing up a chainsaw, we are instantly stepping into industrial safety territory. This isn't just chopping firewood in your backyard. Occupational health and safety standards absolutely apply here. That mandates specific training, protective chainsaw chaps, hard hats, hearing and eye protection, safety boots, and ideally, proper first aid certification.
If you're bringing on help, line cutting is often contracted out to local or indigenous workers who possess these absolutely incredible, lifelong bush skills. But as the person running the project, you have to walk a delicate balance. You have to respect those deep, traditional skills while simultaneously enforcing strict industrial safety and environmental protocols. You just can't assume that everyday, lifelong chainsaw use automatically translates to compliance with occupational health and safety standards. Education and a lot of sensitivity are key here.
So, you got the what, the how, the tools, and the safety protocols. By leveraging smart apps, a really solid safety plan, and a scientifically designed grid, that massive financial barrier is completely gone. The tools are literally in your pocket right now. So, what hidden anomalies is your smartphone about to help you uncover? Thanks for joining me on this explainer, and I'll catch you next time.